Sangeeta. So thanks to the department for inviting me, and to you all for coming. It's a pleasure to be here. I'm really enjoying it. It's a beautiful campus, and I hope you realize what a privilege it is to be on this campus. So I'm going to talk about some of the recent work that we have been doing, looking at the trying to explain land use change in the U.S. in response to ethanol production. So, those of you who were there in the morning, I talked about how production of biofuels from corn in the U.S. Is going to lead to land use change because now you're adding a new demand for corn and expanding the market for it. So this is research with Yijia Lee is a graduate student working with me in the department, and Reaching Meow is a postdoc who was working with me. So some of you already heard the motivation, but really the big picture motivation for doing this research is that biofuels in the US have been really controversial because they, especially from food crops. Corn is a crop that it's actually not eaten by humans directly. It's used to feed livestock. So corn is what is used for producing beef and feeding pigs and cows and so on, and not directly for humans. But you're still diverting a large share of the corn production in the U.S. now for fuel production, and so it has raised a lot of concerns about the effect it will have on food prices in the world market. And apart from the economic effects that when you take, you're raising food prices, the other big issue has been that the increase in food prices will lead to expansion of cropland. And when cropland expands, particularly on land which might have been in forests or land which has been under, grasslands or native, lands which have not been cultivated, it has the likelihood of doing a lot of environmental damage. So there's this concern that you can, there's the effects on water quality because farmers apply fertilizer, effects on biodiversity, and so on. So in general, this is an issue that's raised, there's a lot of, some people saying there's a lot of effect and others saying there is not much effect. And so we wanted to actually do a systematic empirical examination to see how much of the effect was really because of biofuels and how much might be for other reasons, and so on. So that's sort of the big motivation for this. And oops, sorry.
These wires are
I'm surprised it didn't turn off, but maybe we should.
Yeah, should I keep it a little on this side?
Yeah, sure.
Put that.
Right. Okay, let's do that.
That violet.
Should I read?
Pull down screen. Yeah, it's
Okay. Okay. All right. So I just wanted to not be standing in front of the screen, so this works best. Yeah. Oops. No. So this shows how the production of I think this won't maybe show up there. Let's see this one. No. Anyway, so this is no, none of the mouse. Anyway, No, I think it's just, it doesn't show on that. It shows there but not on the screen because of the, it's okay, but I can use it to advance the slides. So anyway, this shows how biofuel production has increased over, as you can see, it's gone up, this is actually showing sort of the share of corn that is used, and as you can see by 2012, almost 40%, and currently about 45% of the corn that is being produced in the US is being used for biofuel production. And the crop prices have, the right-hand side shows the price of corn, and compared to where the price used to be, in say 2000 or so, less than $2 a bushel, the price had gone up to about $7 a bushel by 2012. Okay, so the period when corn ethanol production expanded is also the time when corn prices, more than doubled. And this here shows, the top graph shows how much corn ethanol production has increased. So in 2003, it was just about 3 billion gallons every year, and by 2014, it has gone up to about 15 billion gallons. So it's gone up, 5 times in the last 11, 12 years. The number of ethanol plants has also increased and kept pace with it. And the other thing to note is that it's corn ethanol production has been leveling off now at 15, because that's the government has set the maximum can be 15. So now it's kind of leveling off at that level. So a lot of people have been looking at this question of how much land use change has actually occurred, and has there been an expansion in corn production and crop production in general in the US. And this most recent work is looking at satellite data to look at 30 meter by 30 meter. You can see what crop is being grown, and what land is under crop production, what is under grasslands, and so on. And you can use that to map the changes that have happened over time. So this is a recent paper that is looking at the time period between 2008 and 2012, and showing that corn is grown in the Midwest. So that's the main region where corn is being produced in Illinois, Indiana, Iowa. That's the primary corn belt. And you can see over there that there has been the land conversion is happening largely over there. There also, the black dots here show where all of these ethanol plants, about 200 of those ethanol plants, and they're all located in the corn belt mainly. And this paper looks at within the 100-mile radius of the corn plants, of the ethanol plants, what has been the change in land use. So basically making the point that these ethanol plants are getting their corn from within a 25-50 mile radius, and that's where farmers will have greater incentives to increase their corn production and change acreage. So they find that there's been quite a bit of an increase in land which is being now cultivated, particularly in the vicinity of the ethanol plants. So this research is suggesting that there is a large amount of change caused by ethanol, but they don't actually directly look at whether this change is due to ethanol or not. So the people who are in the class, this is, again, they're comparing the change that has happened between 2012 and 2008. So it's a before and after comparison. They're not able to look at what is, the counterfactual of with and without. So between 2008 and 2012, a lot of things could have changed. And that could, we don't know how much of this expansion is directly because of ethanol or because of other factors. Other data, if you just look at data, contradicts this story about all this land, expansion in crop production. So this is data that is obtained by the USDA, not through satellite, but really through farmer surveys, like a census of farm agriculture land that is done by the USDA. And this suggests that actually between 2008 and 2012, there was very little aggregate change in cropland. So for different crops, things moved up and down. And if you look at corn in particular, so if you look at corn after 2000 and over here, that's the time period we are looking at. corn production really increased, all right? And so did soybeans. Soybeans and corn, they are grown in rotation with each other, so soybean production increased a lot. But some of the other crops like wheat production went down. Some of these other minor crops like oats and cotton and all, those have also been declining. So so there's been a lot of changes of one crop displacing another, but in the aggregate, total cropland did not change very much. Okay. Another paper that was done a few years ago also made the same point, that land use is very inelastic. It doesn't change rapidly with changes in crop prices. And so they looked at the time period 2004-5 to 2009. That's when the ethanol production was just beginning to take off. And if you look at the red line here, that's the changes in land returns. That jumped up a lot between 2006 and 2009. There was a rapid increase in the dollar per acre value of land. But if you look at cropland acres, total cropland acres, between 2006 and 2009, there was a very small increase. And in fact, between over time, it's really there wasn't that big of a change in cropland acres, even though there was this huge increase in land rents. So this suggests that land use is very inelastic and it's not going to respond rapidly to crop price changes. So we've got these two different views, and all of these, none of these have really, again, they're all the before and after version, where they're looking at things over time rather than trying to construct a counterfactual of where you control for all the other factors that can affect land use and then try to isolate what is the effects of ethanol production specifically on cropland. So there have been some studies that have tried to look at the effects of ethanol production directly on crop acreage and using an econometric method, very similar to ours. But a lot of them have been done for the early part of the ethanol expansion period between 2006 and 2012. And a lot of it is focused on smaller regions. It's not looked at things at a national level. So I'll explain why that is important. The purpose of this, our research is that we're looking at a larger time period. And I'll show you why that is really makes a big difference. We're also looking at the entire U.S. and not just the region which is directly focused on where the ethanol plants are located, and in part we want to separate out why there might actually be a larger effect even in areas that are far away from ethanol plants, and why it's important to take that into account. Okay. So if you look at, I showed you on the first slide that ethanol production increased and has now become level. It's been roughly at about 15 billion gallons for the last year or so. But look at what has happened to the price of corn. The price of corn, really jumped up from, over time. From 2005-06, it went up till about 2012. And then corn prices have been going down, okay? Same thing with the total crop price index. If you take we took the 10 or so major crops in the U.S., and again here too, the price index has been declining in the last couple of years, even though corn ethanol production has remained at a high level. If you look at total cropland, at least if you're in an aggregate, this is corn acreage, the blue line, and it's been fairly steady over time. Same thing with total cropland acreage. That hasn't changed a lot over time either. Okay? Of course, if you zoom into that, you can see that corn acreage increased between 2006-07 all the way up to 2012, but now corn acreage is going down. And same thing with total cropland acreage. It kind of ramped up to 2012, but then it's just fluctuating around there. So So it's, the connection between increased corn ethanol production and just looking at the data doesn't remain as clear once you go beyond 2012. Up to 2012, you could make the case that, yeah, the land was increasing, the corn ethanol was increasing, the prices were increasing, and you could say it was all because of corn ethanol. But the fact that this land started declining, land under corn is declining while we are holding our corn ethanol production the same, and prices are declining, really raises questions about, that there's obviously more to the story than just corn ethanol production. Okay? And so you could see here that, so the time period of which you're studying can affect your analysis. Between 2008 and 2012, corn acreage increased by 13%, corn prices increased by 30%, and so did total acreage and the aggregate crop price index. They were all going up while corn ethanol production was increasing. If you look at between 2008 and 2014, corn acreage increased by only 5%, even though corn ethanol has increased or remained constant, and corn price actually decreased by 21%. And same thing there, the total crop acreage increased a little bit, but aggregate crop price index decreased. So the relationship between price and land use, or the relationship between land and ethanol production is not completely linear and in the same direction. Okay. So what we wanted to do is to examine the extent to which the change in total crop acreage and corn acreage in particular over this entire period, 2003 to 2014, can be attributed to corn ethanol production, and in particular, how much of it occurred in the proximity of these ethanol refineries, and how much of it occurred far away from the ethanol refineries, and could have happened because of other factors like crop price changes. So we're not trying to, in this research, we're not trying to figure out how much of the crop price increase was due to ethanol, because that's another complicated step. Instead, we are interested in looking at these two different factors. One is that in the immediate vicinity of the corn ethanol plant, there is increased demand for corn, and so farmers start planting more corn. But crop prices create incentives anywhere in the country to increase corn production. And that's not just for biofuel production, that is also for food production. So, so we use the panel data from 2003 to 2014 and to explain land use, controlling for other factors, and also controlling for spatial autocorrelation for unobserved factors which are spatially correlated, and also controlling for the fact that crop prices, ethanol location, acreage, all these things tend to be simultaneously determined or could be simultaneously determined, so you need to control for endogeneity. Okay. So the reason why it's important to separate out the effects of being near an ethanol plant and far away from an ethanol plant but responding to prices is because there are two ways in which ethanol production affects a farmer's decision to grow more crops or more corn in general. The first is that the price that a farmer receives at the farm gate, depends upon the price of corn at the terminal market, which is like in Chicago, and minus the transportation cost. So the farmer has to bear the cost of transporting the corn from his farm to Chicago. All right, the price that he's going to be getting is minus that cost of transportation. The further away you're from Chicago, the lower the price that you will get. All right. Now, if you have an ethanol plant that is set up in your county, you no longer have to ship your corn all the way to Chicago. You can just send it to the ethanol plant. So your transportation cost goes down, and you get a higher return for the same corn. So your price of corn goes up, and that will create an incentive to plant more corn, right? So you would expect to see that the production of corn would go up near an ethanol refinery. And as the farmer converts land from other crops to grow more corn so that he can supply to the refinery, the production of other crops goes down, their prices also go up. So the price of soybeans will go up just and for the same reasons that the price of corn goes up. They kind of go hand in hand. And overall, the demand for land goes up because you want to plant more corn and more soybeans. So you start converting your idle land into crops. And so you would expect to see not only corn acreage go up, but also total cropland can expand near ethanol refineries. Okay? So that's the first reason. That's the reason why being close to an ethanol plant may increase corn acreage and increase total acreage in general. Okay? But then the other is this price effect. As we've talked about, as more land is converted from food to fuel, the price of crops goes up, and that will create an incentive for anywhere located, anywhere in the U.S. or globally, to increase their corn acreage and their general crop acreage. So it's important to separate out those two effects. The first one will happen near the ethanol plants, but that's not the only land use change that can happen because of biofuel production. You can also have this price effect because all farmers respond to higher prices that accompany ethanol production irrespective of where they are located. And because ethanol production is correlated with these prices, therefore, if you leave out and omit this variable, you're likely to have omitted variable bias. Okay, so your coefficients on the ethanol plant variable can be biased if you don't take into account the effects on other factors that are correlated with that. Okay? All right, so the main, we're basically doing estimating two reduced form equations. The first one has corn acreage as the dependent variable. The other one has total acreage for 10 major crops in the U.S. as the dependent variable. And we're interested in looking at the effect of the price of corn in this regression here. And here we're looking at the aggregate price index for those 10 crops. We also want to look at the effects of ethanol capacity this is all using county level data, so the effective ethanol capacity in that county. Then we control for other factors, input prices, weather, things like that can affect corn acreage. And we have county fixed effects and also control for spatial autocorrelation. Okay, so the other variables that we're including are input prices. Fertilizer is a major input that goes into corn production. If fertilizer prices go up, it can affect the amount of acreage that farmers plant to corn. So you would expect that to have an effect. Population density, because there's increasing demand, there's increasing urbanization, and land is being converted from agriculture to urban development, all over. So that can affect the amount of land, that can affect demand for land and incentives to grow crops on it. We also control for rainfall, because rainfall can affect whether farmers can get into the fields in the spring. March to May is the planting season. If you have a lot of rainfall, farmers cannot get into the field and plant the crops, and that can affect acreage. So you control for that, and then time can have an effect. Time trend can affect acreage. Okay. So one of the things that we have to deal with is figuring out how to define effective ethanol capacity. So remember, we're looking at acreage of corn in a county, and these ethanol plants are located all over these counties. And so how do we define what is the effective ethanol capacity for a particular county? So the way we do that is, let's say you've got these are your different counties, and that black dot is the ethanol plant. So we make the assumption that the ethanol plant is going to get the corn for the plant from a 25-mile radius around it. Okay, so that circle represents the area from which it's going to get the corn, and out of that, a certain portion of this falls within this county, and so we say that portion of the capacity is what is is being serviced by this county, and the demand for ethanol that is affecting this county is the share of that circle that falls within that county. And there may be more than one plant in a county, so you can do the same thing and draw these circles and then add up the shares of all those circles times the size of the plant to get the capacity that is being met by this county, and that will lead to any changes in land within that county. Okay. And again, this is sort of different than what some of these many other, the other studies that have done this. Some of them are looking at the distance of the ethanol plant from the center of the county, but if you take it from the center of the county, then you're actually assuming that all the corn production is only occurring in the center of the county and supplied to the nearest ethanol plant. And that need not necessarily be the case because the corn production is occurring all over the county, and what matters for the plant is you need to have a plant-centric approach rather than a county-centric approach to get the actual measure of capacity that is being serviced by that county. Okay? So we calculate this effective ethanol capacity for each plant, and then aggregate over all the plants that have a buffer zone that's falling within the county, and that gives us the total effective ethanol capacity for that county. Okay. So one of the challenges with doing it is that ethanol plants are going to be located where corn is already being grown, right? So, so in that sense, the capacity is not exogenously given. Corn acreage and ethanol capacity will be simultaneously determined because the plants are going to come where the corn acreage is. So we needed to find a good instrument to be able to do instrumental variables to control for that endogeneity. And so what we do is we look at, sorry, I'm getting ahead a little bit, but anyway, so this is where when we do that ethanol capacity calculation, this is where we find the ethanol capacity is. Most of that is really in this region here, which is where we saw those plants were located previously. And the rest of this thing here is these railroads. That's the railroad map for the US. And what we do is that in order to create this instrumental variable for ethanol capacity, we use the railroad capacity in each county, because ethanol is being transported primarily by rail. So these ethanol plants want to locate where the railroads are. And so by the location of these plants depends on railroad capacity, but the location of corn acreage does not depend on railroad capacity, because corn is transported largely by truck. So we use that as the motivation for using the railroad capacity of each county as an instrument for the ethanol capacity. Okay. All right, so we're using data from, this is county level data. There are about 2,500 counties, and we not all counties produce all crops every year, but we basically say any county that's potentially has grown this crop in the past and therefore has the potential to grow it if it is profitable is included in the sample. We calculate the ethanol capacity like I just described. We use the crop received prices, the price last year, as a price which we think farmers will expect to get, and that's what determines their decision to grow the crop. You can also use futures prices. So corn is traded on the futures market, and you could say, well, farmers are going to use the futures price as a way to determine what the price of corn is going to be, and make their planting decisions based on futures prices. So we do an analysis using both received prices and futures prices. Then you have the fertilizer price index, the population density, and then the climate variables. So as I said, you know, for corn price, we really want to get the expected price. And that could be either, they could say, well, the price we'll get next year is the same as what we got last year, if so that you can use the received prices, or it could be that farmers may say we're going to get, we look at the futures market and that tells us what the price is going to be in October when I'm going to sell the crop. I can see what the price is going to be in March when I'm deciding to make my planting decision, and you can use the futures price. So there's been quite a bit of research that has looked at which is better, is a better measure of farmer expectations. Is it the futures price or the received price? And not come up with a very clear answer. You could either both of them, they're highly correlated and they both seem to work just as well. Okay? For looking at the effects on total cropland, we need to have a measure of the returns to all crops, and we have to also you know, have an index so that we can deflate it. And so what we do is we construct that using this last year's price index for these 10 major crops in our model, and that's weighted by their production, and we use that. Now, when we do this analysis, crop prices are also potentially endogenous because crop prices depend upon crop acreage, and they're simultaneously determined as well. In the aggregate, if crop acreage changes, it'll affect crop prices and so on. So what we needed to do was to find an instrument that is correlated with crop prices but not directly going to affect acreage. And there's been quite a bit of research showing that crop inventories have a big impact on crop prices. The bigger the stock of in the storage of corn, the lower the price of corn is going to be. When stocks are low, then there's a lot of speculation and prices go up. When stocks are large, prices go down. So we use the inventory of the stocks of corn and all these other crops in each state for the price of corn in that state, and do the same thing for the aggregate crop price index. We use the lagged weighted crop stocks for the 10 crops we have. I already sort of explained how we construct the instrumental variable for ethanol capacity. Fertilizer prices could also be endogenous because fertilizer is a key input in corn production, and if corn production goes down, that is going to affect the price of fertilizer. And so we test for that, and then we use natural gas prices because natural gas is a key input in fertilizer production. So if natural gas prices go up, the price of fertilizer goes up, and so on. But natural gas is not an input into corn production. So it's not going to affect corn acreage, but it can affect fertilizer prices and therefore affect acreage. All right, so when we do the, we ran several different models. The first one is just a fixed effects model without instrumental variables. The second column is fixed effects model with instrumental variables. The third column is fixed effects with instrumental variable that corrects for spatial autocorrelation. And in column 4 and column 5, one of them, column 4, only includes prices, does not include ethanol capacity, and column 5 only includes capacity and does not include prices. So we wanted to see what is the effect of excluding one of these variables on the coefficient that you get for the other one, and whether having they are positively correlated actually results in inflating the coefficient when you ignore the other variable. Okay? So results are fairly robust across the different methods that we use for doing this estimation. As you can see, as the lagged corn received price increases, the corn acreage increases. As ethanol capacity increases, corn acreage increases as well. The coefficient on corn price here is much higher than in the previous regressions, and the coefficient for corn ethanol capacity is significantly larger when you don't consider the effects of corn price also. So that should suggest the need to include both of them. Population density does not have a very big effect on corn acreage. Precipitation has an effect, and particularly during the later period. So in some of the regressions. Over time, the acreage under corn is increasing, but at a decreasing rate. If you look at total crop acreage, we find a very similar story in that as the aggregate price index increases, total cropland acreage increases. Same thing with ethanol capacity increasing. Fertilizer price index has a negative impact, and then the other variables, again, over time, crop acreage is declining because land is leaving agriculture and converting to more urban areas. We also wanted to look at whether corn price has an effect on total acreage. Is it just the price of one crop? Can it affect total acreage? And there we find that it doesn't have much of an effect. So corn price by itself does not increase total acreage. And in large part, it's because much of the impact of the higher demand for corn was a substitution of other crops to corn. It didn't lead to an expansion in total cropland. It really just led to a substitution among crops rather than and so it doesn't have a significant effect on total crop acreage. Although effective ethanol capacity still continues to have a positive and significant effect. Okay. So in the aggregate, each of these lines, this is the dark line here is for corn acreage, and the dashed line is for total acreage. And this is a ratio of the predicted acreage for corn or for total acreage over the actual data. And we wanted to see how well the model predicted the total acreage, crop acreage compared to the observed data. And so, if it predicted exactly, everything would have been around 1. But it's not that great, but it's within plus or minus 2 to 4%. So overall, the model provides a pretty good fit to the observed data in terms of being able to explain it. And we can also see that from these maps. So this map is showing at a county level, the predicted acreage, and this is the observed acreage. So you can see this is in 2012, and so you can see here that and this is for total acreage, and this is corn. So corn is mainly, as I said, grown over here. This is total acreage for all the major crops. A lot of the wheat is grown here, corn over there, and some of these other crops are grown in the south. And this is predicted, and this is observed, total and corn. And this is for 2012, and this is for 2014. So even in terms of not only in the aggregate, but even in terms of the spatial distribution and the spatial pattern of production, the model does a pretty good job of explaining where the production is occurring. So now we use this model, and you can actually calculate from the coefficients that you have. You can calculate the acreage price elasticity, and both the acreage with respect to the received price as well as with respect to the ethanol capacity. And we also do that with received prices. This is with futures prices, and this is for corn, and this is for total acreage. And these are for the 5 different models that we ran to see robustness of the elasticity estimate to the different models that were run. So a couple of things you can see here is that corn acreage is fairly elastic. I mean, all of these numbers are less than 1, so it's actually not very elastic. It's quite inelastic. But compared to total acreage, corn acreage is more elastic than total acreage. So total cropland doesn't change a lot with respect to changes in crop prices. Corn acreage does change because there's substitution between crops. The numbers are quite robust across the different methods of estimation, and the effects of ethanol capacity are also fairly small. so 1 gallon increase or 1,000 gallon increase is not going to have a huge impact on the amount of land that is being cultivated, but it is positive. Okay?
Split it between the increase because of the substitution effect and increase because of the increase in the total.
Yeah, I do that on the next, yeah. So now we can actually separate out how much of the, holding everything else constant, if the only thing that had happened was that the price had gone up or ethanol capacity had gone up, then what would be the change in acreage? And you can do that depending on which time periods you take. You can look at the change in crop acreage over that time period due to a particular factor, keeping everything else the same. So you could see that, because of ethanol capacity over the period 2003 to 2014, that led to about a 9% increase in corn acreage. And that, it doesn't matter really whether you go up to 2012 or up to 2014, because the ethanol capacity has been staying constant between 2012 and 2014. So you still need the same amount of land to produce that much level of ethanol. So that's not changed very much. Same thing with total acreage. The total acreage did not change very much, whether you look at things up to 2014 or up to 2012. But if you look at the crop acreage, if you look at the effects of corn prices, then you find that actually the time period of your study makes a huge difference to your answer. Because if you're looking at the time period 2008 to 2014, then the total corn acreage would have actually gone down a little bit. I mean, has in fact declined or stayed about the same. But if you just focus on the 2008 to 2012 period, then you have almost a 9% increase. Same thing with over here between 2003 and 14 versus 2003 and 12. Over this period there was a 15% increase, but here there was only a 6.5% increase. So the time period that you're using can really affect your results, and what this means is that the changes in land use because of prices are transitory. When prices go up, you'll see a lot of change. When prices come down, farmers will do something else. Whereas the change due to ethanol capacity is more permanent, because as long as the capacity is there, it'll require a certain amount of corn. It'll always be a permanent source of demand, and so that doesn't change very much over time. But changes due to crop prices can vary a lot. Same thing with total acreage. The effects are almost double if you look at it over up to 2012 relative to, or at least 30-40% more, versus if you look at it going forward up till 2014. And same thing here, significantly larger in over the shorter period than the longer period. Okay. So then we could look at, so where did this change occur? Where did the positives and negatives happen? And over here, this is A and B are representing changes up to 2012. This is in corn. This is all in corn. This is due to the ethanol capacity. This is due to corn prices. And C and D are up to 2014. So up to 2012, overall, that was, that's where the corn production increased because of corn prices. Sort of pretty uniformly spread across the country. Due to the ethanol capacity, all of the effects are really centered around where the ethanol plants are located. Right? By 2014, the area around the ethanol plants continues to have expanded corn acreage, but look over here. A lot of this land, particularly in the North and South Dakota and even in the Great Plains area, which had otherwise converted, now converts back to whatever it was doing before. So there's a reduction in that land. It moves out of corn production by 2014. This is the total acreage. The previous one was corn, and there again you sort of see the same pattern. The area around the total acreage around ethanol plants doesn't change whether you're looking at 2012 or 2014. Up to 2012, you see total acreage increased particularly in the areas where crops are more frequently grown. By 2014, a lot of that land had actually left crop production in general, because of the reduction in prices. Okay. So in general, what this research shows is that in some ways the findings of the previous research, some saying that land use is very inelastic and others saying there was a big change in cropland, is not completely, you can reconcile both of that. I mean, what we find is that that the elasticity of corn acreage to crop prices is fairly small. And there is not, crop price changes a lot, but land use changes very slowly and very little, and same thing for total acreage. And so it's our estimates for these elasticities are very consistent with previous literature, which has also tended to find that land use is fairly inelastic. But and we also find that much of the changes in as a result of this increased crop prices and increased ethanol capacity for corn were more at the intensive margin. Corn displaces other crops and doesn't affect the total acreage. So these changes at the intensive margin were much larger than the extensive margin. So you can see that the total cropland acreage increased by much less than corn acreage. Corn acreage increased a lot, but that's because other crops like oats and barley and all of that, their production went down. And additionally, that these indirect or any kind of direct or indirect land use changes due to corn ethanol are not entirely due to the quantity of ethanol produced or being in the vicinity of an ethanol plant, but they're also affected by crop prices in general. And even though the amount of corn ethanol production increased over the entire period 2003 to 2014, the amount of this land use change went down after 2012. So assuming that this indirect land use change is constant and it's going to remain, it's permanent and will remain there forever is not correct. And much of this effect of this expansion in corn ethanol capacity, while that has remained steady, but the effect of crop prices has been very transitory and was largely reversed as soon as crop prices declined after 2012. So there's obviously much more to this story on what the effects of corn ethanol have been on land use, and that it's not a clear connection by itself, just observing the data to be able to say that it was entirely due to corn ethanol expansion. All right, so I'm going to stop with that and happy to take some questions. Yeah.
Nancy, you spoke about how food prices may have responded to increased demand for biofood, and mostly we spoke about the substitution that happened at the production level. So basically how the prices are and how different markets are connected because of the fact that there may be changes in the land pattern. But it could well happen even at the consumption level, because even if the changes are not driven by change in the land pattern, but the fact that these crops had initially a food feed dynamics and now you're adding the fuel dimension to it, simply because of that also food prices may go up in general. So
yeah, I mean food prices would...
Is it part of this lecture? I don't think. Did you talk about food prices in here?
Well, food prices could go up for a variety of reasons. Yeah, I mean, we are looking at the effects on, the changes in food crop prices. We are not, those food crop prices could have gone up for a variety of reasons, and there could have been, changes on the demand side. So we know around the same time, actually, demand for, feed in China has been growing really rapidly, and a lot of corn and soybeans are exported to China. So that was another factor that led to higher prices. The price of oil shot up between 2008 and 2010. The price of oil rapidly went up. and energy costs are a huge part of the cost of corn production. So corn prices could have gone up because of that. So there are various reasons why corn prices went up, not simply because of biofuel. We don't try to separate that out, and we are not getting into the question of how much of it was directly due to biofuel, but all we are saying is that at least some part of the change in land use was not because you are directly affected by ethanol production, but for other reasons that led to crop price increases.
And then just one more clarification question. The effective ethanol capacity that we are using as a regressor, the purpose is just to capture. So can you also have maybe a measure directly on the consumption of corn as as ethanol instead of that? Or because that's also because this variable is also perhaps capturing the proximity effect. That's why
This is capturing the proximity effect. So so I'm not sure what your question was though.
Yeah, so can you also maybe have a measure instead on the consumption of how much is of biofuel is getting consumed?
The total consumption of
I
corn
see.
in biofuel plants. So that can be one proxy measure for.
Oh, I see what you're saying. Yeah. No, you could do that. So it's a pretty simple relationship. Every gallon of biofuel needs, so with 1 bushel of corn, you can produce 2.8 gallons of biofuel. So you can convert the ethanol capacity into bushels of corn, but that doesn't, but you still need to be able to allocate that capacity to the different counties. If you just assume that it's all based in one county, but it may be at the border of that county, so then where is it getting its corn from? That's why you have to actually allocate it some way, and this was one way to do it. Yeah.
I have you see, I'm not an agriculture person at all, but your results are very interesting, but not very surprising. And maybe you have mentioned it in the initial slides. You see, the fact that you don't get much of an effect in terms of aggregate cropping area, but in terms of the corn cropped area, is in a sense what one would have expected also, because I don't know about America, but in the rest of the world, the cropping area, the sort of coverage is almost tapering off, and the marginal increment in cropping area comes at a tremendous cost. So I don't know about, whether there is sort of land fallow which can be used,
I mean,
your policy goes, how much they allow for
that
exactly,
too.
so if it's almost reaching the 100% or whatever croppable area, then naturally you don't expect much of an increase. Why would you anyway expect an increase in the crop?
So that's what any common sense would suggest.
Yes.
But this has been such a hugely controversial topic in the U.S. since 2008. So in 2008, there was a paper that was published by a guy called Tim Searchinger. It came out in Science, and that was just the time when the corn ethanol production, was just ramping up. And basically, if you even look at I don't have the title, but it's basically that corn ethanol production leads to large-scale changes in grasslands to crop production.
Also, these were apprehensions.
Yes, that paper changed the course of biofuels.
Maybe you
And-
highlight that because otherwise it doesn't come out as as a fundamentally sort of some piece of evidence which is earth-shattering.
Right.
But
and that paper was it was not an econometric paper, it was a modeling exercise, and they looked at globally what is going to be the effect of biofuel, corn ethanol production on different countries, India, China, Brazil, US, and the thing was that even like in India, they found that corn ethanol production in the US will lead to a 2 million hectare or acre increase in crop production in India, which is so difficult to believe. You can't see where is the 2 million acres left that would be converted to crop production. But that paper had, and since then, the people who are opponents of biofuels have constantly raised this as the big specter that oh, you're going, it has all these big impacts on food versus feed, prices go up, and land use gets converted, and you're losing biodiversity, and you're losing natural habitat, and so this, set in that context, this is intended to show that actually the effects were really not that big, and that these effects change over time, and it's that's
the other
that.
question I have, which is also a follow-up of your other conclusion, that it's the area cultivated, the corn area, which is really showing some impact.
Yeah.
As you said, it's basically a substitution effect that is happening. It would be interesting to find out what is it that is being substituted from.
Right. Yeah.
I mean, which are the, is it cash crops, food crops, core food crops, or,
Right. Yeah, we could look into that, since
that
we have
would be
yeah.
quite interesting
Right.
in terms of the long-term implications.
Right.
if at all.
Yeah. No, that's a good point.
But a
Yeah.
fantastic report,
Yeah.
very nice.
I have a very small question on your econometrics.
Yeah.
You have estimated everything by using the fixed effect model.
Yeah.
Why is it that you did not try or did not report whether it comes from model?
Yeah, I don't know. Actually, that's a good
Normally the
point.
standard
Yeah, you
ways
tested,
to do both and
right?
the house fund
Yeah,
test and
that's true.
go by whatever the house fund
I don't know. We never thought of it. More and more, I find that the papers are not testing this. Nobody reports Hausman tests anymore, and most of the papers are using fixed effects. And in fact, actually fixed effects is a bit of a problem, because that means many of the variables that are fixed over time, you can't include them directly, and so I think we just overlooked that, and that's something I was actually on some of the work we're doing with Sangeeta. I was just talking yesterday. We should test it and see, maybe we can use random effects, but yeah.
sometimes the results can
Yes.
really change.
Okay. Yeah. No, that's something we'll try it out. Thank you. Okay. Yeah. So that's a good point. So let me just take a few minutes to talk a little bit, if you don't mind, about to the students in the room who are not already in a PhD program, but how many master's students are here? Okay, all right. So to the master's students, if you're thinking about doing a PhD, and if you're thinking about coming to the US, I'll give you a 2-minute infomercial. I'm the director of the graduate admissions program in the department, so I would be the person who would look at your application. So if you have other friends who are looking at who are interested in doing a PhD in agriculture, in the Department of Agriculture Economics, but in any broad set of fields related to environmental economics or public policy or development economics, you should look out and see we have go to the ace.illinois.edu website and look at what the program are, what the faculty are doing, and see if this is something of interest to you to apply for. The department has so we have about 35 faculty members. It's a very diverse department in terms of the coverage of areas that are there. And we get a lot of students internationally. Our PhD program, if you get admitted into the PhD program, then you're pretty much guaranteed funding. So we only admit students that we can promise to fund, which is good and bad. It's good because whoever gets in is assured of funding if you're performing okay. What is bad is that that also limits the number of students we can take because we're limited in how many we can fund. So you can be assured you'll be either funded as a research assistant or a teaching assistant. Students from India are really welcome because you come, especially when you're coming from institutions like this, a Delhi school, because you're very well prepared already, and you are all fluent in English, and so and I've sort of already seen how eager and engaged you are, and that's the kind of students that we are looking for. Students who can think for themselves and are really, curious and interested in finding out the answers to things and willing to work hard and sit through 4 hours of me talking You know, so that's you know the kind of students we're looking for, it's normally a 4 to 5 year program where you would do a pretty intensive first year program in core courses of like micro and game theory and all of that. You would do in the second year you would do a research paper that gets you into how to do research, and then you have 2 years, 2 to 3 years where you would work on your dissertation. Okay. All right. So if you are interested, or if you know of people who are interested, please direct them to our department website or to me, and be happy to answer more questions. All right.
Okay. Thank you, Madhu.